We're going to draw in these two graphs together. Let's start with the left-hand side. Help me only construct the x-axis. Generally, in this chapter, we will not draw out the y-axis. We only draw the x-axis. I would like to draw in two graphs, two normal distribution curves that has got the same mean but a different SD. Different SD means different variance as well. So can we draw in a diagram? Just help me draw in a similar diagram to what we have above. A random graph that is like a normal curve, a bell curve, with a center with being the highest peak and symmetrical about that center. So my center value would be mu. Okay, and I would like to label this as x1 curve. Let's draw a second one that has the same middle, but we go and draw something very extreme. Let's have the highest point very, very high up. If the center is very high up, the left and right extreme ends will be lower, looking something like that. Because you are supposed to maintain the total probability to be the same area at 1. Okay, so if the center is very high, when we draw it out, the extreme ends will be very low. That is the idea. And this graph is x2. So this is an example of a curve that has got the same mean, but they will have a different variance. But who has a larger and a smaller variance? How do we try to interpret? Which area is bigger in the middle? Directly at mu, who is having a bigger area? So we can use this word, x2 is more concentrated, meaning a bigger area around mu. You are very high up, you have a big area around mu. So what does this say about the spread of the values? If you are concentrated, means x2 has a smaller spread. Your values are not spread out. It is all in the middle. And if you are not spread out, what can I say about your variance? The word spread is directly linked to variance. So variance of x2 would be smaller than variance of x1. When we are comparing two curves, we look at who is higher. The one higher up will have a bigger concentrated area, meaning a smaller variance.